Welcome you all for today's lecture. Today we are going to see the mux based latches. So you can see here a negative latch and positive latch. So negative latch means it will be a transparent when clock is equal to 0. You can see the input is given to the low input, the low state of the mux, and the output depends on the clock as well as Q, clock Q plus clock bar D, which means that the output of your current state is depends on the present input as well as the previous output. In positive latch, if you take, it is transparent when clock equal to 1. You can see the Q value as clock bar dot Q plus D clock, which means that the output is depends on the present input as well as the past output, and here the clock as well as the input is given to the positive value of your mux. So let's take the mux based latch. You are seeing here which is a D latch. When you are here we are using two transmission gates. One transmission gate is getting the clock as well as clock bar as its control signal, and when you are giving the D value, that we will be having three inverters here. So what is the D latch? Whatever I am giving as input, that I have to get it in our output side, right? So D is equal D. When I let's take clock as 0, what will happen? The transmission gate 1 will become the transmission gate 1 will become turn on, and another the transmission gate 2 will become turn off. So whatever we are passing as input signal, that is D, passing as input through D, it will be held by the latch. When clock is will become 1, then it will be passed towards the Q. So this is mux based latch. Here also the output, the present input can be controlled by the previous output as well as the clock. So the another one example, the mux based latch, which is having only NMOS here. So here also the NMOS gates are controlled by the clock signal, and in addition with that you will be having two inverters. So when I give the clock as 0, the first so the first transistor will become off, being it is NMOS transistor. It will become become off state, so it will just hold the data whatever it is processing previously. So when we are giving the clock as 1, it will just transfer the data from the input side to the other state. So here the being two inverters are connected in cascade, it will just say I am passing the value as high value. That value will be given to the first inverter, then it will be given as the low value to the second inverter. You will get the high at your output side. So this is a D latch actually by using only the NMOS transistor. So when you consider a master slave register, being it is edge triggered, we all already know what is edge triggering. So edge triggering means during the edge of the pulse, I mean clock signal, you are active, I mean the transistor will become active. here we can say it is CMOS will become active. So you will be seeing here two mux based master slave circuit. So we can say it is a D latch. So the first one, if I give D value as input, it will be act as master, being it will be act as master. The output of this one will control the slave signal. So you can see here how it is connected and how the master slave register will be controlling through the clock. So multiplexer based latch pair, by using transmission gate, you can see this is also a master slave register. You can control the entire master slave register with the help of your clock. So when I give clock as 1, what will happen? It will just make my second level of slave latch is active, and if I give during that time my master will be in idle mode. When I give clock as 0, the master will become active and the slave will become inactive. So like that, the master slave delatch registers, we can make use of it. We can control with the help of our clock signal. So when you take the timing properties of mux based master slave register, we all remember that what is a register. Obviously the register will be used for holding the data, storing the data at a time. So it is mandatory to analyze about the hold time, propagation delay, what is setup time, all those things. So when you are considering the mux based master slave register, the hold time is here considered as 0, and the propagation delay will be calculated based on the time taken by the inverter and the propagation delay of the transistors. And the setup time, if you are taking, it will be 3 times the propagation delay of your inverter plus the propagation delay of the transistor. So in order to reduce the clock load, you can slightly modify the circuit like this. So you can see the same master slave delatch. Here we just modified like that in order to reduce the clock load. So two inverters are connected back to back here at the output of your master side as well as in the slave side. So with this we may able to reduce the clock load. So the reverse conduction is also possible in this transmission gate. So if you are taking the non-ideal clock signal, it will just give the D value by controlling we may control the entire circuit by giving the clock signal. So in order to avoid the overlapping of the clock pairs, we need to make the connection like this. The output of my first one will be given to the next. In between the two inverters we are taking the output. The Q bar value is given as input for the slave signal. So with this we may avoid the overlapping of your clock pairs. So that's what we are expecting in our master slave latches, D latches, master slave D latch registers. So thank you. Let's see in our next lecture.